All right, my friends, let's do geometric series. So we've talked about sequences, arithmetic sequences and series, geometric sequences, just like your basic sequences and series. And so now we're going to get to just geometric. But before that, we're going to talk about how cool elephants are. So most elephant sounds can't be heard by humans, but they have a very big vocal range, I guess. That's so cool. That can travel up to 50 miles through the ground. That's insane. So they like talk to each other. Elephants are like the coolest, and ravens, and wolves, and all the animals, but they're just so smart. I want to go see one so bad. Okay, so geometric series. So we've talked about what a geometric sequence is. It's where we're multiplying, right? And so this is how we find the sum of a geometric series without having to add the whole freaking thing up, okay? So a sub n is equal to a sub 1 times 1 minus r to the nth power all over 1 minus r. Write that down, okay? N is the number of terms, a sub 1 is the first term, and r is the common ratio. Okay, so if we're given this sequence right here, so 81, 27, 9, 3, blah, blah, blah. And we want to find S sub 20. Okay, well, first, we need to figure out what R is. Okay, we know what A sub 1 is. A sub 1 is 81. Now, R is 1/3. Now, there's a trick to finding R. And this will always work. So if we look at our series right here, I can take my second term and divide the first term. So I have 27 over 81, which is 1/3. I can also do 9 divided by 27, which is also 1/3. I can do 3 divided by 9, which is 1/3. That is my common ratio right there. Okay? So there's my common ratio, and n is 20. Well, then we're just going to use a formula. So S sub 20 equals 81 times 1 minus 1/3 to the 20th power all over 1 minus 1/3, which I just use my calculator. You get 121.5. So that means if I add up all of the terms up to the 20th term, I'm going to end up with a sum of 121.5. Pretty neat. Okay. Next. Very nice. Okay, so if we have 3, 6, 12, 24, blah, 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 up to 6,144. Well, I know that the first term is 3. I could also figure out the ratio, which is 2. 6 divided by 3 is 2, or 12 divided by 6 is 2, or 24 divided by 12 is 2. But what the heck is n? Help me. Do you guys watch New Girl? It's like my favorite. I've watched it all like probably 3 or 4 times. I just am obsessed with it. But anyway, so we're going to use our formula from last time. So from our sequence, which was a sub n equals a sub 1 times r to the n minus 1 power. Okay, and we're going to use this to figure out what the heck n is, because I know what a sub n is. This is my last term here. So this would be a sub n. I know that a sub 1 is 3, and I know that my common ratio is 2. The only thing I don't know is what the heck is n. Okay, so let's go through and let's figure it out. So if I have 6,144 equals 3 times 2 to the n minus 1, I'm going to divide both sides by 3, and I get 2,048 equals 2 to the n minus 1. Now you could use logarithms to solve this. Or we could look at powers of 2. So like 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. See how far I can go without using a calculator. That would be 128. To the 8th would be 256. To the 9th would be 512. To the 10th. Do you see what I'm doing? I'm just doubling it, right? This would be 1024. Have you guys ever played that game, 2048? That's literally exactly what I'm doing right now. And this equals 2048. Woohoo! Sorry, I'm in a weird mood. Okay, so 2 to the 11th is 2048. So that is what I'm going to plug in for 2048 is 2 to the 11th. Well, if you remember back to our exponents units, I can cancel those 2's and get 11 equals n minus 1, which means n equals 12. I just did a whole lot of work to just figure out what the heck n was. And now I still need to go in and figure out what my sum is. But now I have everything I need for my sum. Okay, so S sub 12 equals 3 times 1 minus 2 to the 12th all over 1 minus 2. Handy dandy calculator gives us 12,285. Cool? Okay, let's do another one. So we have 4, negative 12, 36, negative 108, plus blah, 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 blah. We have to do the same stinking thing and figure out what n is. Okay, so we know a sub 1 is 4, and I also know that r is negative 3. By negative 12 over 4, or 36 over negative 12, or negative 108 over 36, you'll always get negative 3. So what the heck is n? Okay, so I'm going to use my formula. So this is a sub n here. This is a sub 1. This is r. And then this is the thing I'm trying to find. Okay. So then I divide by 4. I get 729 equals negative 3 to the n minus 1. Now I need to check powers of negative 3. And you can't use logs to solve this because it would give us a base of negative 3, which... not cool, not cool, not cool. So if we do like negative 3 squared is 9. Negative 3 cubed is negative 27. Negative 3 to the 4th is 81. Negative 3 to the 5th is negative, what is that? 243. 81 times negative 3. Yep, 243. And so then negative 3 to the 6th would be 729. Look at that. Okay, so that means we are going to change this up here to negative 3 to the 6th. Then we have 6 equals n minus 1. Add the 1 over and you get n equals 7. Now we can go through and figure out what our sum is. So that's going to be 4 times 1 minus negative 3 to the 7th all over 1 minus negative 3. Which is 2,188. Booyah. Shakalaka. All right. Be good. Okay, this one. So I have n equals 1 to 25, and n is 2, or our formula is 2 to the n minus 1 power. So the ratio is always the number being raised to the power. So my ratio in this case is 2. Now my number of terms here, before I even do that, a sub 1, I'm going to plug in my bottom number, boom, boom, and you're going to get to the 0 power. Anything to the 0 power is 1. My number of terms is 25, and then I can just plug it in. So 1 times 1 minus 2 to the 25th power all over 1 minus 2, which you end up getting this giant thing, 33,554,431. Whoa. I would love to have that much money. So if anyone wants to donate to my fund, just bring me a check or some cash, whatever you want. Okay. Wow. Okay. So this one, now my r again is always the number being raised. So it's negative 3. A sub 1, I need to plug in the bottom number. So I need to plug in 6. So if I plug in 6 up here, I get negative 1 or negative 4 times negative 3 to the 6 minus 1 power, which is negative 4 times negative 3 to the 5th power, which ends up being 972. So that is my first term. Now, if you remember how to find n, if we just do 20 minus 6, you get 14. But if we count all the terms, so if we go 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 terms there. Okay, it's because when you subtract, you're like excluding one of them. And it's like, that's not cool. We don't want to exclude one of them. Okay, so we have to add that back in. So we're going to put plus 1 and you actually get 15. Okay, so now I have 972 times 1 minus negative 3 to the 15th power over 1 minus negative 3. We get that other giant number. So now it's 3 billion. So now we're talking like Elon Musk or whatever his name is, who makes all the freaking money, who we won't share with us, but whatever. Sorry. 3,486,784,644. Wow. Okay. Let's switch gears. So now we have to talk about infinity. So like, if you guys have ever thought about infinity, it's a really, really crazy concept that we just like can go off forever. And you don't actually hit a number or like, think about the universe. Like the universe is infinitely big. Like we are on a teeny tiny marble in the universe and it just goes on forever and ever and ever. This is a fractal zoom right here. I don't know if you guys have ever heard of what a fractal is. Look it up. So get on Google fractal zoom. Or not on the Google, get on the YouTube. So get on YouTube and Google fractal zoom. And you can sit there and just be mesmerized for so long. Like they'll put cool music to it and stuff and they just zoom in forever. Like it's a mathematical thing that you can just keep zooming in forever. You can zoom in forever, which is why this is on the infinite page. You can zoom in forever and all the pieces, like everything just repeats itself. So like it's a self-duplicating thing. Super crazy. You can put math to it. Math is insane. Okay, so if we want to find the partial sum of the following infinite series. So we have a half plus a fourth plus an eighth plus a 16th. Well, let's just figure out like S sub 1. So if I add these together, I get 0.5. If I add a half and a fourth together, I get 0.75. If I add a half and a fourth and an eighth together, I get 0.875. If I add a half and a fourth and an eighth and a 16th together, I get 0.9375. If I add a half, a fourth, a eighth, a 16th, a 32nd, I get 0.96875. I'm getting really, really close to 1. And there's another way we can think about this is if we add a pie. So I'm going to split this pie in half. And I'm going to eat it. Okay? And then I'm going to split the half in half, and I'm going to eat that. And then I'm going to split that half in half, and I'm going to eat that. And then, because that's really what we're doing, like this was the half, this is a half, this is a fourth, this is an eighth. So we're just splitting it in half. Well, I'm going to split it in half again, and I'm going to eat it. And then again, and I'm going to eat it. And then again, and then again, and then again, and then again. And like really, if we really think about it, we could keep splitting in half forever, but in the real world, the pie's going to be gone at some point. Like at some point, we're just going to eat the whole thing. So this is approaching 1. This is getting closer and closer and closer to a whole, which means when that happens, when we are approaching a value, it is called a convergent series. That means it converges on one point. Really cool. That means we're adding up an infinite number of terms and it ends up just equaling one thing. Like, how does that make sense? How do you add up an infinite number of terms and it equals one thing? Well, that's because, like, if you think about the pie, the pieces get so infinitely small that they don't matter. Okay? But let's think about another one. So if we have 1/2 plus 1 plus 2 plus 4 plus 8, well, if I just, S1 would equal 0.5. S2 would equal 1.5. S3 would equal 3.5. S4 would equal 7.5. S5 would equal 15.5. If I added 16 to that, I'd get 31.5. And then they would just keep getting bigger and bigger and bigger. This is going to blow up. Like, this is just going to get so big that it's infinity. Like, it never stops. It never approaches a number, whereas our other one does. Okay, so when that happens, this is called a divergent series. When the series does not approach a certain sum and it either, whoa, that was a weird word. It either blows up to infinity or it blows the other way to negative infinity. Okay, either way, it's blowing up. Like, it's like dividing by 0. Not really, but it just blows up. Okay, that's called divergent. Okay, so if our R value is less than 1, the absolute value of our R value is less than 1, it's going to be convergent. It's going to just go to one point, and that's what it equals. If our R value is greater than 1, it's going to blow up. So like in this case, I was multiplying by 1/2 each time, which means my R equals 1/2, resulting in a convergent series. Whereas this one, I was multiplying by 2 each time, which means my R equals 2, resulting in our divergent series. Okay? Okay, and this is how you can, this is a formula to figure it out, where you don't have to draw the picture out every time or like go through a list. So we have a sub 1 times 1 over 1 minus R. Okay? So let's look at this one. So first we want to figure out, is it convergent or is it divergent? And if it's convergent, can we find the sum? So for this one, I first need to figure out what R is. So if I do 1/4 divided by 1, I get 1/4. If I did 1/16 divided by 1/4, I'd get 1/4. So this is a convergent series, which means that I can use my formula. So a sub 1 equals 1, and then s sub n would equal 1 times 1 over 1 minus 1/4, which is 4/3. So that means if I add up this infinite series here, it's going to just end up equaling 4/3. Really weird. Crazy? Yeah. Okay, what about this one? So 2/3 plus 8/3 plus 32/3, blah, blah, blah. Well, if I do 8/3 divided by 2/3, I end up getting 8 over 2, which is 4. So my R value is 4, which means that's too big, and it's divergent. This is going to blow up. This is going to go to infinity. Okay? This one, 5.8, 3.48, blah, blah, blah. Well, if I divide 3.48 and 5.8, I get 0.6. 0.6 is less than 1. So this is a convergent series, and I can find the sum. So my first term is 5.8. And now I can do 5.8 times 1 over 1 minus 0.6, which is 14.5. Neat. Oh, okay. This one, so remember the ratio is always what's being raised to the power. Well, the ratio here is 1/4. And I need to figure out what my first term is by plugging in, it's convergent, sorry I didn't say that, by plugging in 1 to figure out what my first term is. So my first term is going to be -2 times 1/4 to the 1 minus 1 power, which is just -2. And I literally just used my formula. So -2 times 1 over 1 minus 1/4, which is -8/3. So if I added up all the terms in this, I would end up getting -8/3. Okay, this one. So if I have 8 times -5/2 to the x minus 2, well, -5/2, the absolute value of that is 2.5. That is divergent. It's going to blow up, okay? This one, my R value is -3/4. The absolute value of -3/4 is +3/4, which is less than 1. So that means this is convergent. And I have to find my first term. So to find my first term, I'm going to plug 2 in up here. So -6 times -3/4 to the 2 minus 1 power, which is 4.5. So then my formula is S sub n equals 4.5 times 1 over 1 minus -3/4, which is 18/7. Very cool, very cool. All right. Okay, love you, bye.